Question 9. So we're looking at a triangle, we're looking at sides and angles, so it's trigonometry, it's not a right angle triangle, so we're going to use this. So we've got area, we've got sine rule, we've got cosine rule, and we're just going to pick out which one we're going to use. So we need to work out the area of field 1. We have enough information there to go straight into the half AB sine C. The capital C is your angle, which makes this 50. C, A and B, it doesn't matter which way around they are. So you put it all in, you get 402.2. You can't do the same with field 2 though, because you don't have enough information, but you can work out the whole thing, and you can just subtract field 1 from it. So if you read the question, it says find field 1 and hence find field 2. So use the answer here to find this one. So field 2 is impossible to do directly, but you can work out the whole thing. To do the whole thing, again, just a half AB sine C, but this time you've got the 50 for your C, it's 35, but it's 40 along the bottom, rather than the 30 that we use for field 1. Work out the two answers, subtract them, and you'll get what field 2 is. Okay, over onto the other side. So we want to work out the perimeter of field 1. We've got two other sides, we just need the third one. So that's the cosine rule. We know it's the cosine rule because it's to do with three sides and an angle. If we had one of the other angles, so that we'd have some pairs, then you could use the sine rule as well. Sine rule needs two pairs, angles and sides. So this is the cosine rule. Notice that there's a capital A. The capitals are the angles, so this is the only angle we have. So this is capital A this time. It was C last time, but it's A this time because of the capital. So small a is here. B and C, again, doesn't matter which way around they are. Put it all in, you should get 28 metres. Okay, on to the next one. So, it's all about aircrafts and stuff. First thing I notice is that there's a right angle triangle here. And on diagram 2, there's a right angle triangle and there's another right angle triangle, but we'll come on to that in a minute. So, C part 1, we need to find the length of time that sound takes to get along this line. So we need the time along this line here. Fine. So I know my distance, speed, time triangle, so don't suck toes, so I remember that one. A little bit of a weirdo thing, but yeah, D at the top, yeah, if you remember that, you're grand. So we can't work out the time from this picture, but we can work out the distance, this distance from the picture. So you can do it with trigonometry. You can put an X there. And you'd be using cos, or you can notice that if you've got 90 degrees here and 45 here, then this would be 45 as well because of 180, so 45, 45 and 90. Once you spot that you've got two 45s, then you've got an isosceles triangle, so this is 10, and then you can just use Pythagoras instead. So yeah, either the normal cos, B over C, or you can go to Pythagoras. Either way, you should get 14.142 kilometres, and then you've just got to convert that distance to a time. Be careful doing that because they give you the speed in metres, whereas you've got a distance in kilometres. So either change that to metres, which I did, I'll just change it to 14,142, or change this to kilometres per second, so it'd be 0.343. Do either of those two things, so make them both kilometres or both metres. Divide them because of the triangle and you get 41 seconds. And then part 2 down here. Right, now it's double I. It's not part D, it's C double I. So what that tells me is I'm going to have to use this 41 down here. Okay, and also they give you the answer of 41 so that you can use it down here. So even if you don't get this right, you should still be using the 41 down here. So let's have a little read. So constant speed 255. Okay, by the time yeah, fine. So we have to just find the angle at the very top here. So we're looking to find this, and we know that we're going to be taking 41 seconds for this to happen. So the plane has 41 seconds to move over here. Read the question out, it's the same amount of time. So this is 41 seconds of the plane travelling at 255 metres per second. So we can work out this distance from P1 to P2 from those two bits of information. So let's come down here. Done a little drawing. We want the distance. It's the speed multiplied by the time. It's the 255, which is how fast the aircraft is travelling, multiplied by my 41.23 blah, 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 from above. Okay, the exact answer, not the 41. And we get 10,000 metres, or 10.5 kilometres. So now that we know it's 10.5 kilometres, we know that this little bit here is 0.5 kilometres. And that comes from up here. This is 10 and so is this, because this is 45 as well. So if this is 10, this is 0.5, there's extra little bit over here, 0.5. So here's my triangle. And we just need to work out the angle, and it's easy from there. It's normal trigonometry, it's the tan. You have to do tan minus 1 to move the tan, but you should get 2.9 degrees, and we're done. We'll finish the rest of this question in part 2.